very generous. Thank you. So my name is Chris Horder. I'm, as Yuri mentioned, I'm part of the solution architecture team based in Sydney. For the last couple of years, I've been working with financial services customers, and you can imagine they have quite a lot of data. So, one of the things that they've talked, or I talk to them about a lot, is how they manage their data. And we can see this trend over the last few years where we're having multiple personas actually use their data platforms. And not all of them are skilled data engineers that understand every aspect of data lakes. So we're seeing this movement to a number of frameworks out there, which I'm going to be talking about today, on how they can actually support multiple personas and actually more use cases with these transactional data lakes. So as I mentioned in the intro there, I'm going to talk about some of the challenges with traditional data lakes. I'm going to introduce, if you don't know already, like open table formats, or OTFs as I refer to them today. I'm going to jump into a couple case studies and see how some of our customers have actually used OTFs to actually make it easier for people to access their data, but also get some really good outcomes as well. Then I'm going to dive deep into Apache Iceberg. The reason I'm going into Iceberg is that we're seeing a lot of customers use it, but also I'm going to use it as a bit of a frame to describe like some of the functionality that we're seeing people use OTFs for. So, and obviously after that I'm going to do a quick summary, and then we're going to jump into how you guys can get started, can get a bit hands-on with OTFs in your own lab accounts. Okay, so what are some of the challenges that we've been seeing with traditional data lakes, right? I guess initially data lakes were kind of loaded at night, like we'd spend a couple hours chucking all the data out of our transactional databases, landing them in S3, and then we'd build some nice presentation layers about that. What's happening now is that people want their data more like closer to when it's actually transacted. They want it more like near real time, right, in our data lake. And so that's where we've had to build like these really complex ETL processes to update and upload to our data lakes. And that's become really brittle, right? Like you've got data come in, there may be a new column, there may be something of this, and that's actually been proven to be quite brittle. And then you've got to think about the consistency of your data lakes as well at that point, where if someone's loading data in, but it's only half loaded some of the files, and someone does a query on that, you may get some wrong data. So it's a data quality issue. And so we want to really find an easy way to address that, especially as we scale the number of people using our data lakes. The other thing that we have to think about, and I guess this kind of comes with continuously updating our data lakes, is that we may get like inconsistent performance when we're actually processing the data. So if we're loading in lots of files like every 5 minutes or every hour, we might actually see some files that will be inconsistent sizes. And as we saw in the last talk, that was about glue, and if you're processing that with distributed computing, some of your processors over this side might be having lots of little small files, and then some over here might be having some really big files. So you can actually see some, I guess, complication in managing all of that. So we want to see consistent sizes across all of our files as our processing layer looks at those. Okay, and then probably the biggest one that we're hearing about is like complying with regulators. So with the right to be forgotten and GDPR, you need to be able to delete data easily from your data lakes. And I'm going to be talking about some of the ways that our customers have solved that challenge with using a transactional data lake. Okay, so I used this term before, open table format. Like, what's that? So it's OTF for short. But we're seeing like 3 main frameworks play out in that space right now. We've got Apache Iceberg, which was born out of Netflix. Sorry. We've also got Apache Hudi, which was born out of Uber, and then we've got Delta Lake, which is obviously born out of our Databricks partner. And they all have different sort of, I guess, views of the world of how little bits and pieces should work, but generally they're there to achieve the same functions. And I'll talk through some of those like differences as we go through today, and it really may help you decide when you get to your use case which one is the best one best fit for what you're trying to do. So let's talk a little bit about how Zoom used Hudi. So I think we all know who Zoom is, right? They've obviously got a very large user base, but they also have a lot of regulators that they need to comply with. So one of the big challenges they had was they needed to actually be able to delete data from their data lake. Now this was actually taking up 3 hours to delete 1,000 records, and it was actually creating a lot of operational burden for their data pipeline teams. And also you could imagine the scale that they're operating at. Now they were actually, their data lake was actually sitting on a HDFS volume at that point, so you could imagine how much that was costing as well. They weren't using S3, so they really wanted to evaluate how they could best meet these two challenges. And so they looked into OTFs and they found that Hoodie was their chosen framework to work with. And what they've been able to do with that is they've able to move their data onto S3. So that saw a straight up a 90% cost reduction straight away. And then they were also able to use the transactional nature of Hoodie to be able to delete records much faster. So I think it's got up there that they've been able to delete 1,000 records in under 2 minutes, right? Which is a big change from the multiple hour jobs that they used to have before. So you could imagine the operational ease that came with that as well. Okay. Now another customer, Orca, they had a slightly different challenge where they had many pipelines and were creating new features into their applications that needed data. And so what they were doing was like every time they had to build out a new feature, they were having to create new pipelines. And all of those pipelines had to understand exactly how the data was being loaded. They had to build data quality checking into all of this, and this was actually proving a real challenge because they didn't have a transactional nature. So they actually adopted Apache Iceberg and have been able to see a 50% cost reduction, or I guess resource reduction, in the amount of time they have to spend on managing the data platform because they're simply using a framework to deal with the transactional nature. So really great, and it's actually been able to scale with their features as well. Like as they add new features, they simply drop in a new table and off they go. So I've been talking a lot about these OTFs, like where do they fit into like I guess a traditional data platform. You can see here sources, ingestions, we've got our catalog is still the same, and then the consumption layer is still the same, but where the biggest change is around the storage side. So Iceberg and Hoodie, they all sit on top of S3, and they're really just a metadata layer that sits on top of like that traditional data storage that we've seen in the past. So what we really need from our data lake is actually supportability of those new frameworks that we're talking about, which happens quite easily with a lot of the managed services from AWS, but also the ecosystem of the data world has actually really heavily adopted all three of these frameworks. So what are the common features that all of these OTFs provide, right? So I've talked a lot about transactional nature. So they're all ACID compliant. So what that means is that if you've got a whole bunch of providers that are actually, a whole bunch of users that are selecting data from your data lake, you can actually still be uploading data there. In the past, we've had to pause jobs and things to make sure that our data was consistent and we weren't reading inconsistent data. ACID transactions have been there to be able to support that. And you can see there we mentioned like a couple of the frameworks that have support for that, right? So Spark is an obvious starter, but then you've got Trino and Flink and all the others that have really good support for all of these OTFs. You can update and delete individual records, right? So you can see where that flows into the regulatory requirements. You can actually now run deletes and updates on your data lakes, and I'm going to talk through exactly how that works today at a storage layer. That's normally been something really easy to do in data warehouses, but very hard to do in data lakes. Now, write-heavy use case support. What do I mean by that? That's actually being able to ingest a lot of streaming data really quickly and have more closer to near real-time data inside your data lakes. All the OTFs are really built around that feature set. A couple of others that I think are really important to keep in mind is time travel. It's sort of you kind of get that for free by using an OTF, and that's the ability to be able to look at what your data looked like, say, prior to the last load, a week ago, a month ago, a year ago, depending on how long you want to retain your data. It's a really handy feature, and we'll touch on how you can use that today. And then the other one, which I kind of touched on in the challenges, is the file size management. Because we're storing this metadata layer about like what your data looks like on the disk, you can actually go and optimize that through using maintenance tasks. So they're pretty much the primary ones. So when we dive into this three frameworks that I've been talking about, you can actually see, this is where we start to see a few differences. The top two are, I guess, table stakes really for OTFs, but then we start to get into things like schema evolution, right? And you can see here Iceberg as an example has really good support for partition evolution. In the past, it's been very hard to change partitions once your data is in there, but Iceberg has a really great way of dealing with that, and I'm going to actually dive in deep to how that works today. The other thing down in this table here that you might find interesting is the write modes. And you can see there it kind of mentions copy on write and merge on read. I'm going to dive in today to exactly what that means. So when you come to your workload, you can actually understand which one of those I should be using. Okay. Now, I've been talking a lot about OTFs. Here's where the AWS support is at for those. You can see the 3 different types here. And AWS services have pretty good coverage of all of those. So if this in any way impacts which OTF you're going to go with, make sure you keep up to date with this because this is changing quite a lot at the moment. But yeah, as you can see, here's the coverage from the AWS services. Okay, so with that, I'm going to dive a little bit deeper into Iceberg. And I picked Iceberg for 2 reasons. A, it's kind of like, its goal is to be simple, right? So users should be able to use it quite easily and not have to have too much like knowledge about how the underlying storage is set out. And also, I think the feature set is quite good. So as I mentioned, it was open sourced by Netflix some time ago. It's been backed heavily by AWS, Snowflake. I think Confluent has recently have a number of releases around it. Starburst and so on have all got really good support for it. It's got good framework and library coverage, with as in Flink and friends. And it supports all 3 file formats that I guess are mainly used. Some of the key features that I really like about Iceberg is the hidden partitioning, and I'll talk about what that means in a couple of slides. That's a really big feature and a really good item that has made it much easier for the broad set of data users to be able to get into these platforms. The other one I'll call out here is I've got it there as high performance design for S3. What that means is that it's not reliant on a list objects call from S3. And the reason why that's a good thing is that you can imagine if you had 300 users all querying data out of your data lake at the same time, and they're all asking S3 for a list of objects in there, they'll probably get inconsistent results from that. And also, it means that you've had to store that in memory and work out your partitions and everything all these times. What we're able to do with the OTFs is actually be able to use the metadata to actually shortcut that. So it's actually a really quick and fast way to get a good performance gain out of not having to do a list objects there. And the last one I'll call out is the merge statement. So anyone that's come from a data warehousing background will really appreciate upsert or merge. That's available in Iceberg as well. Okay. So what's the difference between what we've been doing in data lakes up until now and then what OTFs provide, and specifically Iceberg in the case I've got up here? So you can see there like a traditional Hive table. We've got it sitting in our S3 bucket. We've got some prefixes there that are describing the partitions. So you can see there it's got year equals 2022, month and day partitions, and then our files are just sitting in there. So you can imagine if you came in and selected from that I might be reading from a partition there that is only half loaded. And so that's where this transactional nature comes in really handy. So what have they done in OTFs to address this? They've actually created a metadata layer that actually sits in S3 right next to your data. And so you can see there, that's probably the primary difference, right? Your data's still sitting in there. It's still sitting in partition prefixes. Not a big change, right? So what does a table layout look like, right? So I sort of had this nice big box there that said metadata. So what's inside that, right? That's kind of what we've got here. So there's actually 3 layers involved in an Iceberg table, and this is actually very similar across all OTFs. You can see I've got the catalog there. Now that catalog might be a Hive Metastore, it might be the Glue data catalog. It could be a catalog that supports Iceberg. Then we've got, this is probably a new concept, is the metadata layer. Which is sitting there, which is made up of a bunch of files. Depending on your OTF, it's actually different how that's laid out, but this is the Iceberg version here. And then we've got our data layer, which hasn't really changed at all, right? And that's still sitting on S3. Okay, so the catalog is actually how we enable some of the transactional features of that. So the catalog, you could imagine, has got a table in there, and then it points to the metadata. And it's actually pointing at a metadata file in the case of Iceberg. So when you go to run your query, right, like your query is going to check with the catalog, hey, where's the data? And it's going to return back that it's got a point at this metadata file for the Iceberg. So you can imagine there, that's where we're going to go for our first understanding of how our catalog, our table is laid out. So the metadata file is actually really important. You can see in this example here, there's S0, S1, S2. That actually S is actually standing for snapshot. So you can think of a snapshot as actually a transaction, right? So when the transaction happens, a new metadata file is created and a new snapshot is inserted into there. So you can see here, when snapshot 2 happened, we created a new metadata file and our catalog started pointing at that new metadata file there. Right, and that's how we can, you can see there, that's how we can enable time travel as well, right? Now there's a couple of interesting bits that get stored in this metadata file. So your partitions get stored in here, your schema gets stored in here, a whole bunch of bits and pieces like that. Now the manifest list, which is the next layer down, right, like that actually stores data about like, okay, so what, how many rows are in this, each of these tables, how many files are in there, how much was added, deleted in all these snapshots. And so that's a really important file. Then that actually points at your manifest files, right? Manifest files actually store about the location in S3, but they also store some statistics about the data that's sitting in the data files, right? And so that's how you can do a lot of optimization at query time, right? Which is really, really handy, and that's where a lot of the smarts come in to how you're querying the data. So it's really important to keep that in mind. Okay, so we've talked about the layout on the S3 and the metadata. What are some of the advantages of that we've seen with your DML availability inside Iceberg and others? Is you can now use insert statements, you can use update statements, delete, and merge, right? Really handy features that will be very familiar to a lot of the data warehousing folks here. All of a sudden you can do that now in your data lake. Okay, so one of the challenges that we've always had in data lakes has actually been schema evolution. Now Iceberg and the OTFs all kind of handle this in different ways. With Iceberg, it actually stores all of this stuff in the metadata, right? And it actually gives an ID to every column, right? And so if you drop or rename or move a column, that's all actually stored in the metadata files, right? And it actually aligns to IDs in there. So if you're adding a column, you don't actually have to reprocess all your data files or anything. It's just a metadata change, which you could imagine is instantaneous, right? And same with the rename of a column. You can see in this example here, it's gone from name to first name. Again, you don't have to reprocess all your data. It's just a change in your metadata catalog. So that makes that much easier. Okay, so I mentioned hidden partitioning before. It actually sounds like it's an unusual term. I hadn't heard about it until I started working in this area. And so what that means is like we've got a typical Hive query up the top there where we're doing a select statement. We then have a where clause, which is actually probably a business-based where clause, like between 9 and 5. And then we've got this event date down the bottom, right? And that's actually where I've had to understand that my partition key is an event date, right? Which means I have to know a lot about the underlying partitioning that someone else may have defined. And if I don't remember that, the query platform is actually going to query all the data in there possibly. So we really don't want every engineer to have to understand how the partitioning was done. So what Iceberg does is it actually stores the partitioning in the metadata file, so you don't actually have to know about what the partitioning keys are and everything. And that becomes important when we start talking about how you change a partition later. So you can see here, in the Iceberg query, which is at the bottom, I don't actually need to include event date there, which makes it much easier for people to use, right? So that's all sorted out from the metadata. So how do we define partitioning in Iceberg? You can see here, here's a standard create table. You can see the partition by clause here. And I've actually got 3 partition samples here. And you can see here I'm actually using what they call a partition transform. And it's kind of, I guess, like a function, right, where you can pass in parameters. And so in this case, I'm using the bucketing function here. It's sort of like a mod, if you will, mod 16ing over the ID. So I'm actually spreading it across a number of prefixes in S3. And then using the days transform from the timestamp column. And then I'm using the category from the thing there to actually partition my data that way, making it pretty simple to read and quite easy to use. And I've listed down the bottom there a number of other transforms that you can use that are pretty common for most use cases. Okay, so what happens if on day 1 I picked the transform to use month and my data's all going in day after day? and it's building up for each month. And you can see in this example here, February and May have gone in and my partition is month. What happens if I actually see, hey, you know, I want to start querying the data by day or by hour, and all of a sudden my processing, it requires it to read all of the data in the month, right? So I want to change the partitioning to day. And because I'm using Iceberg and it's got that metadata layer there, I can actually just alter the table and change the partitioning to by day. Does that mean I have to rewrite all the data? No, it doesn't. It means I can just, new data inserted will just be going into the new partitioning scheme, right? So you can see here, for April, I'm actually going into day 1, day 2, day 2, 3, etc. And so you can see there the whole month fills out that way. Now, what does that mean when I do a query, right? Like, see here, I didn't have to think about the partitioning scheme. I, as a user, could just query, I just want everything between the 15th of March and the 3rd of April, right? Now, what happens at query time here? It's still going to have to look at all the data that's sitting in there for March, which is pretty, not very cost effective, but it's still there. But when it comes to April, I only have to look at 3 days worth of data, which is really cost effective. So by that, it's been a really easy change for us to go that way, and I didn't have to reprocess all of this data. Okay, so let's dig a little bit deeper into transactions and how they work on the file system layer. So you can see here I've got my catalog, which we talked about before. And you can see when I do an insert, it's created a new snapshot, and then it's created the manifest list, the manifest file, and also the data file that's got everything in there. That's great. So I've got my records in there. Everything looks good. Now I want to come along and I want to update some of the data that I stored before. So here's snapshot 2, right? So what happens? It creates a new manifest, a metadata file. With snapshot 2, it points to the manifest list, and the manifest file, and a new data file there. And you can see I'm using the copy on write approach to how I update data. Now, what does that mean? What does copy on write mean? Exactly what it sounds like. I'm going to create a new data file with the changes in that and all the existing data in there and put it over there. So it's a full copy. So now when I read the data, it's actually just going to go straight to that new data file and it's going to be up to date. So you can imagine here, if those data files are really large, this could actually take quite a while. So how are we going to address that? I'll come to that shortly. Now, imagine I needed to delete some data, right? It's again going to be the same approach. I'm going to completely rewrite the data file that's impacted by the delete into a new file without that new data being there. Again, that could take some time, but your read path is going to be really quick, and I'll explain why now. So the other approach is the merge on read, and this is where when you make an update, right, we're actually going to only put in changes into these new files that are created, right? So when you think about an update, it's actually a delete then an insert, right? So what we do on merge on read approach, we're going to create a delete file, and you can see that there it's got delete position, and then there's the Parquet file there. And inside that is actually a position marker of where the delete happens in the original data file. And then I'm going to create a new data file with the new data in it. Not all of the data, just the new stuff, right? So you can see that that's actually quite efficient from a writing perspective. I'm only putting in the changes into there. Now what happens with a delete, right? Like we've seen there in the update, we've created a new data file and a delete file. For a delete, we only create a delete file, right? So you can imagine that could be very fast to do deletes there, because I'm just putting in position markers of all of that. So when do I use which one, right? So I've talked about the copy on write, I've talked about merge on read. When do I use which one? So you can imagine if you're doing large bulk updates, copy on write is probably going to be what you want to use. If you're doing streaming ingestion, you're probably going to want to use merge on read, right? And you can see down there where the impacts are, right? So you can see if I'm using copy on write, it's going to be the slowest for updates and deletes. But it's same for inserts. Inserts are not impacted, but updates and deletes. Read latency is going to be fastest on your copy on writes. Now you can see there's this new one down here, equality deletes, which is even faster at inserts and deletes, but it's the slowest at reading. So that's a bit of a trade-off. And how equality deletes work is it actually stores the ID or the primary key of the record that you're impacting on, right? Whereas the other one, actually, the position one, records the position in the file. So If you are doing a lot of inserts or updates and merges, then you may, and you're not keeping up, you may want to look at moving to equality deletes, but keep in mind that it will impact your read performance. Okay, so let's jump into time travel. We've talked a lot about transactions, and you can probably see how time travel works. We're using the snapshots that have been created over time to actually say, hey, I want to look at the data like 4 snapshots ago, or I want to look at it as it was at this date. You can actually query those metadata tables. There's some syntax that's available if you look it up in the documentation. You can actually query those to see when all the snapshots happened, and then you can change your queries there. You can see in these examples for the timestamp as a version, etc., etc. Okay, now one of the more interesting features of Iceberg here is tagging and branching, and I kind of think of this like Git for your data tables. So in this example here, I'm using a tag. You can see in the first example there, I'm creating a tag called end of week 01. Right, so maybe every week I want to take a snapshot of the table as it midnight or 5 p.m. or whatever every Friday or Saturday. And I want to have an easy reference to the data as of exactly that time. And you can see in here that I can say as of version, but you can also say as of timestamp, and you can store that for 7 days, 365 days, whatever your requirements are. And that becomes really important that I need to retain it for X many days, because as you could probably see, we build up a lot of files and data files and metadata files over time. And so you do need to run maintenance jobs every now and then on this to keep everything tidy, basically. Now the other one here you got is called create branch, and that's where you can actually branch your data and start doing work to it. And so maybe you've got a couple of steps that you want to make sure are the right thing to do with your data. You want to maybe run a new batch workflow on it or something of that nature. And then you want to see what it looks like at the end. Maybe you want to compare it back to the original source. You can do that all through SQL. But then you can actually merge that back into the main line of your table. So it's actually a really interesting data engineering feature that you could look to use there. Okay, so with that, I've gone through the depths of Iceberg there, but you can also probably see how that plays into the other OTFs and how that could affect your decisioning of which one to use. I've put up a couple of ideas there about when to use which ones. So for Iceberg, if you're looking for simplicity across all your developers, you can see how hidden partitioning and things work. I've also got there, Hoodie is really great for streaming use cases. That's what it was built for. And then if you're in the Databricks ecosystem, then Delta Lake is a really good choice as well. Keep in mind the AWS service support when you're picking these, because they all do have different parts that are supported. I've put up here a blog post that actually goes really deep into making a detailed decision about which one to use. And if you want to get hands-on with it, you can use the OTF workshop there. You can do that in your own account, so you can actually look to run it in a lab account, and where you can actually get hands-on with all 3 of the OTFs that I've talked about today. And that's using Glue and a couple of the AWS services to do that. But if you're willing to look at have a play, definitely get into that. If there's been something here that's been of real interest and you want to dive deeper into it, so maybe around some of the AWS services, you might want to check out Skill Builder. There's like over 600 free digital courses on there. There's labs that you can get hands-on with, and there's also role-based games if you want to get into that as well. So with that, thank you so much for coming to the last session of the day with me, spending the time with me, and yeah, we'd love your feedback as well. So again, thank you very much. Thanks, Yuri.